Alright, these are our notes for section 7.2 on graphing polynomials. So we're going to continue the ideas that we learned in 7.1 and how those things like the leading coefficient and the degree and the end behavior all affect the graph, and we're actually going to graph these polynomials. Alright, the first thing, these are your steps here at the top. First thing you want to do is complete the given chart and plot the points. So you'll have an x and a y, or an x and an f of x. Remember, f of x is the same as y. You want to plot those. And you can put them in your calculator to get the table. Remember, you can hit y equals, put in your function, hit second and table, and then just copy down the table for the values you need. That's fine with me, so you don't have to plug in each one every time. So use that, that's a shortcut, and fill in your table. And then you want to connect those points after you've plotted them in the given order. Sometimes they'll skip. The examples we'll look at will count by ones, but every once in a while they'll skip maybe two numbers, and then they'll go back to the chart and they'll count by ones again, or they'll skip some. So connect them in the order that they're given. Now there's a couple things to think about, in particular the degree, and you want to think about what the degree means. Okay? Remember, it's the biggest or the greatest exponent in an equation or an expression. And what that tells you is how many changes in direction there are in the graph. And you need to make sure that they are the same. Okay, the same number. So if my greatest exponent's a 5, I should have 5 shifts in direction, 5 changes in direction on my graph. They should match. That's one thing to watch, one way to check as you're going to make sure that you're doing the problem right. And the last thing is that you should be neat, because eventually we're going to estimate values, and if your graphs are sloppy, then your estimations are going to be off. Alright, I'm going to give you an example here, and what I want you to do is just graph this example. Okay, follow the steps that I've given you at the top there. Complete the chart and then connect the point. Plot the points and connect them in order, and then check your degree for this example. We've got f of x equals x to the 4th minus x cubed minus 4x squared plus 1. I'm going to go ahead and point out for you that the degree is 4. Okay, that's the biggest exponent, which means there should be 4 changes in direction in this graph. So what we're going to do is we're going to put y equals, input our graph, hit second, and then table, and copy our values. I'm going to wait for a second while you do that in your calculator, and then you're going to fill them in. Alright, those values should be 9, -1, 1, -3, -7, and 19. Notice that last one's pretty large, which means it may or may not fit on our graph, depends on how far we're counting. But it should tell us that it's either going to go up really high or low, down really low. So the end will point up or it'll point down. Okay, let's plot these. -2, 9 would be right here. -1, -1 down here. And then 0, 1, 1, -3, 2, -7, and then 3, 19, and that would be way up here. Alright, now we're going to connect them. We're going to connect them in the order that they were given. So we're going to start here. We're going to go down, and then up, down, and then all the way up to where our 19 would be. And there's our graph. That's what we would do. Okay? Notice that it does change direction 4 times. It goes down, up, okay, which matches what our degree is. Our degree should be 4. And that's the basic gist of what we're going to do today. That's the hard part. The second part is that we're going to go through and we're going to add a new idea to this. Okay? Relative max and relative min. Now a relative max is a high point on the graph. And a relative min is the opposite. It's going to be a low point on the graph. One way I usually tell people to remember this is that the max is going to be a hill, the top of a hill, and the relative min is going to be the low point in the valley. Okay, so that's what we're looking for. We're looking for hills and for valleys. We've got an example here, a basic one down here at the bottom, and I just want to point out where the maxes and the mins are. Okay, this is going to be a relative max because it's a high point, it's a hill. These are going to be relative mins because they are the low points, they're the valleys of the graph. Okay, so we have one relative max here, and we have two relative mins. And that's what we're looking for, high points and low points. So in our graph over here, we have one relative max. It's right here. We have two relative mins, one there and one there. All right, pretty basic idea. Now we're going to add one thing to it. We're going to estimate the x values. Okay, and it's important that we estimate the x and not the y. So we're going to look at those points, and we're going to draw a line down or up to where they hit the x-axis. So I'm going to re-sketch our graph just a little larger so we can see it. It's the same thing from up here at the top. I'm just going to make it larger so that we can see it a little better. So we come down. There was one point. Here was another. These are all the ones in the middle of the graph. 0, and then we went down to 7 down here. And we connected them, and then it shot way back up. Now I realize that's not the greatest, but what we're looking for is where it hits the x-axis. So if I draw a line through here, this is my min, remember my relative min, it hits at -1. So that would be my x value. I would say relative min at -1. My other relative min, we draw up to the x-axis, hits at 2. So we would say relative min at 2. Now the max, we don't draw up, we're going to draw down. And it hits at the y-axis, so our relative max is at 0. And that's what we mean by estimate their values. So the first thing you got to do is tell me how many relative mins and how many relative maxes. Second thing is to tell me, estimate what their values are, their x values. Okay, we're going to go ahead and go to the back, and we're going to combine all this together in addition to the real zero part from last time, and we're going to do one example. Okay, our example is f of x equals x cubed minus 4x squared plus 5. So the first thing we need to do is put that in our calculator and complete the table. Go ahead and do that now. I'm going to pause it while you do that, and I'm going to see if you can do that on your own. You should be able to. Alright, the values for our table are 0, 5, 2, -3, -4, and 5. So the next thing we do is we're going to plot these. -1, 0, 0, 5, 1, 2, 2, -3, 3, -4, and then 4, 5. Now notice your degree here is 3. That means we should change direction 3 times. It looks like since this one's lower than the next point, we're going to start by going up and then come down and then go back up again. So there's our graph. The first question asks how many real zeros there are. Remember, real zeros are how many times it crosses the x-axis. Well, it looks like there are 3 in this case. Second thing is that we need to estimate their values. So we want to see where they actually cross. Well, here's 1, and it crosses at -1. Here's another. It's somewhere in between 1 and 2, so let's say 1.5. And the next one is kind of in between 3 and 4. So we could estimate it at about 3.75, 3.5. I'm going to be pretty lenient with it, but obviously it's not 4 because it's between them, and it's not 3 because it's somewhere between 3 and 4. So just pay attention to what you're doing. And those would be our estimations for that value. The next thing we need to know is how many relative maxes and mins. That's the high and low points. Here's a high point. Remember, a high point is a max. So we have one relative max. Here's a low point. So we have one relative min. We have one of each. The last question here is to estimate their x values. So we're going to draw lines up or down to the x-axis and see where they hit. The relative max we draw down, and it hits at 0. So we would say 1 relative max at 0. The relative min we draw up, and it looks like it hits right there. So our relative min is at, and it hit at 3. And those would be the answers to our problem. We've answered all the questions they asked for. Now, this is what it will look like on your homework. You'll have to graph it on your own. It'll ask you for zeros and to estimate their values, and then the relative maxes and mins and to estimate their values. So if you have questions on this, bring it to class next time. And those are your notes for section 7.2 on graphing polynomial functions.